So last session we completed the requirement elicitation part. So now we know how to plan for the requirements, what all activities we do during the first 1 week where the project planning is happening. And then we also understood the various techniques to engage the customers and understand the requirements. Okay. Now, parallel to this, simultaneously, when you are understanding the requirements, you should also start documenting them. Okay. So there are some known ways in which you can, frameworks which you can learn to document your requirements. Because it's not just a pure, you're not writing a big paragraph in English or explaining it that way. There are some frameworks which are far more efficient, which are more pictorial, and which are more comprehensive to capture all your requirements. Okay. So the next few sessions would focus on those techniques. How do we document our requirements? So primarily from a functional point of view. So all our functional understanding that we have gained through the requirement elicitation techniques, how do we convert that into a written document, a BRD? Right? So that would be the focus of the next few sessions. Okay. So last session I briefly introduced you to the various techniques. Right. So broadly, these 4 ways. Structured analysis, like I said, is outdated. So the data flow diagrams are never used. So at least I have not used in the last 10 years. So it's that outdated. So structured analysis is a bit dated. The data flow diagrams we don't really use anymore. It was more relevant in the earlier days where there were procedure-oriented languages, but we don't really use them anymore. So I'll cover that, but very briefly, because you will never use that. Just that since you are working as a business analyst, you should be aware of the data flow diagrams, at least that. But don't spend too much time on that. Even for your interviews, nobody is going to ask you to draw data flow diagrams or ask questions on that. You can safely ignore that. Okay. Now, what is more important is the ER diagrams in that, because all our data modeling would depend on that, right? So we need to understand about that as well. Okay. So today's and maybe on Monday's session, we'll cover these 2 diagrams, and then we'll move on to the object-oriented analysis, which is use cases. That's the most important topic. Okay. Yeah. I have this document which is a much easier read onto the data flow diagrams. And rather than go through the PPT, I would prefer to explain it using this diagram. Okay. So I think this diagram aptly summarizes what a data flow diagram does. Okay. Now, so rather than calling it as one diagram, it's basically a collation of diagrams. So the overall data flow diagram, there would be multiple diagrams which you draw, and it's similar to what you're doing is you're depicting the functionality at multiple levels of granularity. So the topmost level is the most abstract, and that level covers the very high level view of what the system does, right? In fact, the whole system you will consider as one single process, one single task, and then all the elliptical boxes that you're seeing here, elliptical symbols, those are your external actors who are involved interacting with your system, right? So most of the times you either give the input or take the output, right? If I'm using a system, I either provide some input to the system, or I would take the output, either view it as on the screen or I'll take it as a report, right? But basically an output is coming out, right? So any of the external entities which are interacting with the system would either give input or take output. So that's all what you're doing at the highest level. Right? So you're considering the whole system as one single process, and then you're showing all those external entities, interacting with them by providing input and output. Right? Now at this level, the detailed requirement is not coming out. So what you do is you will break down this process into sub processes. Right? So this one process you've broken down into two processes, right? And give a little more details. So it's something like that zoom in feature. So if you zoom in, you can figure out like there are two more features in it, right? So you're drilling down and explaining the functionality in a little more detail, right? And similarly, you'll do that again for the next level, right? So you'll pick up each of those processes, and then you will expand that and explain it in a little more detail, so it results in another data flow diagram. So the more levels you go further, the more details you would get. So the bottommost layer is the most comprehensive, the detailed step, and the topmost level is the most abstract level and giving you the bigger picture, right? So you tend to create these diagrams, as per the need. So there is no standard guidance which says that there has to be only level 2 or level 3 DFDs. But the general norm is that you stop around level 2 or level 3 DFDs, nothing more than that. By the time you have had that clarity in the process of what exactly, how exactly the process needs to happen, right? So, so first let's look at some of the components of a data flow diagram. Right? A data flow diagram would primarily have these four components. The external entities are the people who are using the system. Right? We represent that using this elliptical symbol. Then there are processes. So any activity which is happening in the system is shown using this process box. It's a rectangular box, and then you will mention what is the name of the process in that, and then also give an identifier to it. And then you would be storing some data in your system, right? So that is shown using a data store, wherein one side of the rectangular box is is empty, is hollow, and we call this as a data store, right? We will have the identifier and then the name of the data store, so that you can clearly identify what data is being stored there. And then the arrows which shows how is the data being transferred between systems. Right? So like I said again, this is a flow. You will start off with a level 0 DFD, wherein you will just consider the whole system as one single process and all the external entities providing input or taking output from it. Right? So let's look at a small example. Right? So let's say you want to develop a pizza information system, a pizza management system, whatever you call it as. So there is a customer who is providing you the sales order, right? And then you would so you would process that sales order, and you would provide the pizza along with the receipt, then and the delivery note, right? You send the invoice, and then we get the payment details as well. So these are the interactions with the customer. Then the pizza information system would also prepare a purchase order and send it to the supplier. The supplier would respond with the stock quantities, and that are updated in your system, right? So these are the external entities, and the whole system you are considering as one single process. Now what we can do is we can break down this whole system into multiple sub processes, right? So if I try to do that and then figure out what are the key processes that happen, I will end up with a level 1 DFD, something like this, right? So there are 7 processes which are broken down into, right? So the whole pizza management system, I've said that it comprises of these 7 sub processes, and each one of them, I'm explaining it in a little more detail here. So saying that the pizza information system would have a sales process wherein you'll take the sales order and then store it in your database. Then there is a production control process which will take in all the sales orders and then the quantities available and then prepare the schedule of production, okay, which is stored in your database again. Okay, then you would prepare the pizzas based on the schedule and then you'll take in the recipes and then update the stock accordingly. Okay, then there would be a stores process which will determine the raw materials required. Okay, depending on what raw materials are required, you will create a purchase order. Okay, you'll purchase those materials from the supplier, right? And then you would have a shipping module wherein you will send in the delivery note and the sales order. Then there would be a billing or accounts process wherein you take the payment and then the receipt and provide the receipt as well, right? So broadly, these are the 7 sub processes that I could gather from that system. Okay, so this is the level 1 DFD. Now what I would do is I'll break down each one of these sub processes again and then get the next level of details. Like if I pick up this purchasing, right? Now the purchasing ordering the raw materials, right? So it's still not clear about how the purchasing would happen, right? So first I have to create a purchase order and then send it to the supplier, and then the supplier will provide me the stock quantities, right? So all that I've covered at one single process, but I can give a little more details. So if I break it down, it would look a little more like this. Okay, so this is a level 2 DFD, right? So level 1 DFD had the 7 sub processes, and now for level 2 DFD, I'm creating for ordering the raw materials. There are 2 sub processes again in this. One is I'm creating a purchase order and sending it to the supplier, and also storing those details. Then the supplier is supplying me the quantities, and then I would go and update my database, right? So by this level, I think I'm clear. There would be like 2 screens, one for creating the purchase order, and one once you receive the delivery, you'll have to go and update your stock quantities, right? So at this level, level 2 DFD for ordering the raw materials is good. I think I'll stop here. For some cases, maybe if you don't have the clarity yet, you might want to draw the next level of DFD and explain it in a little more detail, right? So that's how you would approach the data flow diagrams. Okay. Now again, you are not going to create this anymore. So it's just that just understand the structure. If you are given a data flow diagram, you should be able to understand it. So that's the level of knowledge you require. I would, in most cases, I would say you can safely ignore this. We are not going to deal with data flow diagrams anymore. It's an outdated technology, outdated method. Okay. Yeah. So let's move on to the next topic, which is of interest to us, which is the ER diagram. Right. Now, structured analysis consists of 2 methods. One is the data flow diagram, which shows how is data processed in your system, and the second one is how is data stored. Right. Now, so we have this concept called ER diagrams, which basically tells us how is data processed, how is data stored in our systems. Okay. Now, first question: why do we need to store data in our system? Right. Now, data is we need to store data because we want to retrieve at a later point and then use that data, right? So if you are not storing the data in a right format which can be retrieved at a later point, so there is no point in storing the data, right? So for example, let's say you want to figure out what all transactions has a customer performed. Okay, so if that information is not available, then it's difficult to and there's no point in maintaining all that transaction and order information, right? You should be able to clearly, you would generally store that in data when store that data because you can use that at a later point, right? For example, if you have stored all the orders which a customer has placed, and maybe all the billing here you have done, you might want to retrieve it at a later point for various reasons again, right? So that's the main reason for storing the data, right? So if it is not useful for a later point in time, there's no point in storing that data, right? So what ER diagrams does is it gives you an effective framework to store it in the right way, so that retrieval of the data becomes easier at a later point in time, right? So let's say if you're developing a shopping cart kind of application, so you can store all your customer information like his address, his credit card details, his preferences, and then when you're placing the order, you will use that information, and then once your orders are placed, then you'll store that information as well. So there needs to be a structure. You cannot just write it into a notebook kind of thing and then store it, right? So it has to be stored in a much more structured format. So that ER diagram gives you that structure of how the data should be stored. Okay. Now, given that context, so let's look at how a database is created. Right? So when we have these databases in a structured format, we can retrieve it. But how do we create that? How do we create that database? It involves these 7 steps. First step, we clearly identify what data needs to be stored. Okay. Now this is a step where we as a business analyst would play a major role, right? So when we say I want to store all the customer information, we should be clear about what all are the details about the customer that you want to store, right? Now you should clearly understand what is the user requirement, what needs to be stored, and what all needs to be related among that. So all that information that you are capturing would be the basis for creating the conceptual design or the high level design, which we do using an ER diagrams. Okay. Now ER diagrams are primarily created by the architects. So we will not create the ER diagrams, though we are learning about how to create them and all. In a typical BA role, you are not going to create an ER diagram. So there are specialists who are experts in creating the ER diagrams, and they would do it. The data architects and the data modelers. So you will not generally get into the ER modeling. However, we should be able to understand an ER model, so we would learn how conceptually a ER model would look like. Okay. Then once you have that ER model, a conceptual framework for storing the data, you would convert into a particular technology, like Oracle or SQL Server. So there are multiple technologies, multiple types of databases, right? So you have an Oracle database, you have a DB2 database from IBM, and then you have a SQL Server database from Microsoft, right? So there are multiple database technologies. So your ER diagram is converted into that, logical design or the underlying technology like DB2 or Oracle, depending on what technology you are using for your application. Okay. So once that high level design is created, once your database is created in that particular technology, then you would refine it further. So refinement would generally be done for 2 things. One is to reduce the redundancies and make it more efficient, which we call it as normalization, and then bringing in the consistency and integrity checks, right? So that all the data is related and you're putting in all those checks and balances so that the data is not deleted incorrectly, right? Again, mostly it's a DBS activities. Your involvement would be very low in those. Then you would create the underlying database in a particular on a particular hard disk, right? You would allocate space and then create indexes and all those activities wherever required. And finally, you will give access to the people who can who need to uh, uh, access the database, right? So the security controls are implemented. So these are the 7 steps usually which happen in the creation of a database design, right? And your involvement primarily would be at the requirement stage. So let's take a small example. Let's say you're creating a database for a bank's systems. So let's say you want to store all the loan information, right? So that you're creating a new loan system. So you'll figure out what all information you need to store. So you need to store information about the customers, their loan accounts, what all branches do we have, what transactions are happening on those loans, right? All that needs to be covered as part of your specification. Then you would arrange this information into an ER model, which is a logical model without any particular technology, without getting into any particular technology. Then you will confirm with the client whether the ER model is correct. All those relationships, the rules and all are correct, right? Then finally you would convert it into a particular technology and then create the physical design, right? So that is how a typical ER model